Good morning, everyone. Welcome to the third day of Gateways 2021. I'm glad that you're all here, and I hope you enjoyed the 2 days before. I would like to remind everyone there's a code of conduct. We are kind and respectful to each other. And so this morning is a panel. And after the panel, we have 4 working sessions in parallel. And in the afternoon, we have, again, lightning talks, 6 lightning talks. So with this, I'm Chandra Gesing. I'm from the Discovery Partner Institute at the University of Illinois, Chicago. And it's my pleasure to moderate this panel. So the panelists are Shannon, Stephen Brandt, Sean Cleveland, Kerk, and Mark Perri. And they will discuss the vision for science gateway technologies for the next 10 years. And with this, I give it directly for them to introductions. And Stephen, take it off.
Okay, so my name is Stephen Brandt, and I'm Assistant Director for Computational Science at the Center for Computation and Technology. One of the things I bring to this vision of the future for gateways is the importance of VR. I found this blog post, which I think is kind of inspiring, about somebody who spends their whole time, their whole day, every day working in VR, basically throwing up big screens in VR and using that as their work environment. So far, it's only been for special people and pioneers. And when I look around at the internet, at what people say about working in VR, all I see are negative things, like it's not for everyone. And it can give you motion sickness. You might forget what reality is, and all kinds of negative things. And what this makes me think of is Douglas Adams' famous quote, where he says, anything that was around before I was 15 is just part of the normal world, and everything that appears from 15 to 35 is exciting new technology that maybe I can get a job in. And after 35, I think this is against the natural order of things. And I think there's a lot of people who see VR that way. So I hope you're not one of them. And I hope I can convince you that we're all 30 or 25 at heart or whatever. And this is an exciting new thing. I think it's going to become normal to work from orbit. Next slide. So just in the spirit of this, you may have heard that VR is being used for cows to make them feel like they're in a wider open pasture than they actually are. And it actually makes them happier and produces better milk. I think that cows are just the first non-human animal to be put in VR. I think we're going to see many others. And I think that just gives you an idea of just, I think, how widespread this technology is going to be. And anyway, so now I'd like to talk about some of the potential of it. Let's go to the next one. So one of the things I work on are coastal applications, and we're constantly, providing data sets in the form of big square arrays of numbers, right? Which you can generate by, writing little Python scripts or whatever. And I guess my feeling is this feels wrong. I mean, I feel like I should be able to just put on a pair of goggles and sculpt a bathymetry or a topography or a wave generator or a barrier for coastal wetlands and run it. It seems to me that this would be a far more natural way of doing things. And, one of the things that I've been thinking might be a good application to build at some point is a citizen science for coastal wetland preservation. So you can find all kinds of papers about people making various structures offshore to try and preserve a coastal region, and then they do a simulation to see how well it works. If we had a nice VR interface where students or ordinary lay people could just draw their own, paint in 3D their own barriers for wetlands, some of which are underwater, some of which extend above the water, and so on. We might make some real breakthroughs in that area. In addition, of course, we could get more intuitive visualizations of complex data. There was a quote I saw. I don't know where it happened, where it was, because I couldn't find it again. But the idea is, one of the things we trade in VR is we lose the ability to show people exactly what we want them to see. And in exchange, we get to put them in a world where they can interact with the data. So one of the things I think VR will offer us is new ways to combine code and graphical interfaces. And so Jupyter Notebooks are one of the nice things that do that now. I mean, if someone puts up a new way to serve Jupyter Notebooks, that even counts as a gateway. But it preserves the power and flexibility of the command line, and it just sort of takes you, gives you some of that additional flexibility at the cost of having to understand more. But notebooks can still be used by people who don't fully understand all the things that are going on in them. So do they have obvious VR extensions? Do we have a walkthrough laboratory instead of a page? I think that's a possibility. I think another thing they point to is the possibility of using low code or graphical environments to program. Graphical programming languages have not quite caught on yet. I mean, they do exist, but they're becoming, those kinds of programming environments and low codes are gaining traction. And I think that VR might give them the push to really go more mainstream. And I think in general, and probably other people will talk about this, what gateways are going to need in the future is the ability to be more composable, rather than just saying, here's an application that you can run with certain parameters. Here's an API to doing one aspect of coastal wetlands research or gravitational astrophysics, and you can plug it together with other ones, and that's your gateway. So that's my vision for the future of gateways.
So the next one is Sean.
Hello, everybody. My name is Sean Cleveland. I'm with the University of Hawaii and the TAPIS project. So sort of tying into what Steve was talking about with being able to, compose things from different gateways. I'm looking at, interoperability within the next 10 years, seeing a lot of gateways that can connect to other gateways to leverage, some of the capabilities, applications, data, resources, sort of like that. And I think there's a lot of efforts that are already underway to help support sort of this vision of multiple gateways connecting to one another and sort of sharing these resources. So Maytal Dahan yesterday kind of spoke about SGCI's effort for computational research descriptions and application resource descriptions. That's, I think, one of the ways towards this. So there's kind of three major areas, I think, that we'll be seeing a lot of movement on. So if you want to go to the next slide. One of those is APIs. I think there's a lot of work on making sure that new gateways have APIs that are developed to standards that support code generation, validation, documentation, so they can be widely adopted by a number of technologies and a number of developers. I think we are seeing movements towards some of these implementations as more like services, so platforms as services and software as services, so that a lot of folks don't have to build all of the foundational infrastructures, and they can leverage some of the other things and some of the projects that are currently trying to do this. We hit the next slide, is data management. So in order to interoperate, there needs to be standardization on how we describe data, how we serve out the data. There's a lot of efforts towards movement for open science and some of these emerging standards. So I think that's one of the pieces that's going to fall into place in the next 10 years to be able to support, chaining together some of these gateways to perform, more complex things than they currently can do, being bigger than the sum of their parts. So next slide. Finally is sort of the identity and access management piece here. So if we're going to connect all these things together, you're spanning multiple institutions. So there's issues with trust that are there. And so there's projects that are underway, obviously, to connect a lot of these things, like CI login and common side tokens. The conference last week and early this week for some of the cybersecurity stuff was kind of looking at some of these things. There's also this issue with some of the multi-factor authentication that's come into line that's kind of an issue for long-running and multi-resource workflows that we sort of have to sort out. So that's sort of my vision for interoperability.
Thank you. Shannon? Shannon, if you are talking, you are muted.
You're not muted. My name is Shannon Bradley, and I'm a senior project manager at NCSA, the National Center for Supercomputing Applications at the University of Illinois. And I'm going to be talking about science gateways for everyone. So whenever we sit and we think about the next 10 years of science gateways, so far we have been talking about mainly research and how gateways can connect researchers and things like that. But over the next 10 years, I see gateway type applications spanning all kinds of areas, from research to business, from human interaction to HPC, from biology to the arts. And as we move forward with gateways, these can be created to not only keep researchers in mind, but to keep everybody in mind. So what can we grow out of this? Next slide. So for instance, whenever you're talking about VR, let's add some more things to that and come at it from the viewpoint of virtual tourism. Earlier, we were talking about, before the session started, how so many of us traveled so much during 2019, but COVID hit and you couldn't travel anywhere. And everybody is getting to the point where we would like to see something new. And some places are, I feel, are still too crowded to go safely while we're still fighting things with COVID-19. And what about people who are not physically able to travel to all of these historic sites and want to be able to not only look at pictures of them, but actually get a fully interactive, immersive experience for looking at places that other tourists typically are able to go to physically. So a gateway could take all the amount of historical data that we have from a site, which could be hand tracings from some of the original maps. It could be old photos that could be compared to new photos of what the site looks like. We can do all kinds of different LiDAR scans, infrared scans. We could have original audio recordings from people who were connected with the original creation of one of the buildings, or someone giving a personalized tour or personal experiences. Incorporate that with maps and put that all together in a large database that is managed with machine learning and artificial intelligence, so that you can put up a picture on the screen and you'll be able to walk through the site. You can click on items and you can have 3D renderings that you can turn in your hands. You can listen to a tourist guide, give you information about the site. The picture in the bottom right is from a cathedral in Italy. And whenever you look at some of the infrared pictures that are from various places within the cathedral, you can see graffiti and handwritten notes from the people who are actually built the cathedral, but you can't see them with just you're looking at it with the normal eye visual spectrum. And so you're able to, either with a cell phone or with VR, zoom in and look at things that you would not normally be able to experience just on a regular tour of a site. One thing that my son started doing, who works for the National Park Service, whenever he first heard me talking about things like this, is during COVID, they started sending the park rangers down into Mammoth Cave to take pictures of archaeological items or fossils, say of a prehistoric fish. And while the researchers couldn't go down into the cave, if you gave them a 3D rendering of the area, they were able to continue their research solely by looking at the item in 3D or in virtual reality. So there are so many things that can connect research with virtual tourism. Next slide. And you can also add in archaeology. For instance, the Cypress Institute is just starting to work with the Paphos Gate, and they're wanting to figure out what is the best path to walk through this site. And so what they're actually doing is letting people who come there give their suggestions on where they would like to walk, and they create their own path through a virtual design of the Paphos Gate, so that when the city authorities and the architects actually design the final walkway through there, it will be designed with the input of local stakeholders, tourists, international experts who have all been able to experience this through virtual reality. They're also starting to place kiosks in some of their exhibition halls, where you can take a vase that has been excavated from the Paphos Gate. They have taken all the pieces and virtually put it together, and you're able to, either with your phone or in VR, sit and manipulate the vase and look at it like you're holding it while you're there in the museum. So I think that over the course of the next year, by taking Gateway's 10 years, Gateway's technologies, and combining it so that everyone can benefit, it's going to contribute to a feeling where everybody belongs, working on research together.
Great, thanks. So the next one is Kerk.
Hello, everyone. Good morning. My name is Kerk, Key Associate Professor in the College of Media and Communication at Texas Tech University. I'm a social scientist of gateways and cyber infrastructure. And today, I would like to briefly share some thoughts on how the social sciences can benefit from gateways and vice versa in envisioning the next 10 years. First, let's consider computational social sciences as a growth area. One example came from adapting existing platforms from one domain to another. The technology underlying NanoHub, while originally developed for nanotechnology research, it can be reused for other domains. A prime example, thanks to Shannon, she was the one who introduced this to me, is the social media macroscope developed by Joseph Yun and team at the University of Illinois at Urbana-Champaign. It features a tool called Smile, which can perform analysis and techniques such as NLP, sentiment analysis, etc. It also has another tool called Brandt Analytics Environment. Although SMM is still in its early phase as a proof of concept, but it shows how the social sciences can benefit from gateways in this example and help us envision more possibilities for the next 10 years. Next slide, please. Okay, all right, so I would like to share some thoughts now on how gateways can benefit from the social sciences, especially in the area of technology adoption. Here, I briefly highlight a framework by Rogers called the Diffusion of Innovations Theory, which explains, describes, and predicts the adoption, uptake, and spread of innovations across many different contexts. First, let's talk about the attributes of gateways. Developers will be wise to assess the relative advantage, perceived compatibility, simplicity, triability, and observability of the gateways in the target domain community. If all 5 attributes can be maximized, a gateway is more likely to see user uptake. And the second point here is, let's consider understanding the users. The lead users in this case are usually venturesome. They don't have You don't have to do much to win them over. The second group, we have the early adopters. They are visionary. They don't always jump on board right away, but once they do, they usually can influence many others in the next group to adopt. And the third group, we have the early majority. They are very pragmatic. You need to really show them how gateways can help them with their publications and their careers with a reasonable amount of time investment. If it is too much time to learn and troubleshoot, they won't do it. Then we have the late majority. They are really cautious, and they usually will adopt only when there's a lot of pressure from the community. And finally, we have the laggards. They are usually very suspicious of new technologies. It is best to leave them alone and not waste your time trying to convince them. Next slide. Thank you. So to conclude, this is a very brief presentation. I would like to close by suggesting to watch out for the unconscious mindset of if you build it, they will come, and modify it to if you build it, promote it, and they, the users, trust you, they will come. Perhaps gateway projects can consider developing a communication management plan to accompany a project. In such a plan, the PI could think through activities and strategies for outreach, advertising, public relations, trust cultivation, and relationship building with new communities of users to increase uptake for the next 10 years. And with that, I conclude my presentation. Thank you.
Thank you. And now, Mark Perri.
Thanks. I'm Mark. I'm a chemistry faculty at Sonoma State. We're a state college in Northern California, getting some rain now, finally. And I run an educational gateway for chemistry undergrads called ChemCompute. And so I wanted to talk about the future of educational gateways. And educational gateways, I mean, all gateways, the goal is to broaden access to these computational resources. But for educational gateways, it's particularly important. If you're an undergraduate university, for example, you don't have access to a lot of the expertise that's required to install and maintain computational packages. You might not have access to a university cluster to do those computations on. And the expertise you have in your department is really limited. If you have a small department, maybe just 5, 6 faculty, you might not have somebody who is an expert in computational. Maybe everyone is an experimentalist. So it's important for educational gateways to meet these challenges and to provide these facilities. And for education, it's important. Our gateways are not just to teach our students how to do these computations. I mean, that's, of course, one learning objective. But in general, we're trying to get our students more confident with computers. A lot of our students, especially in chemistry, think that their career is going to only be lab-based. But if we can teach them that there are careers open that are computer-based, I always think that that's a win. And even if they are going to do some lab-based career, they're going to need to use computers in that career. And it's always important to get them used to using computers early on. All right, next slide, please. And so for the path forward for education, I think that, as was mentioned earlier, Jupyter Notebooks are playing a large role now. I see a lot of users working on Python or maybe Julia Jupyter Notebooks to do their computations. And when you do that, you really teach the students how to break down a problem and perform a simulation to solve it. In order to deploy Jupyter Notebooks, we need some sort of container infrastructure. And usually, currently, it's sort of locally deployed. I think it's going to be important moving on to get some sort of national infrastructure for Jupyter Notebooks because they become so ubiquitous. And it's tough to rely upon local resources to host these Jupyter containers. I've always looked at jobs that people have run on my gateway, and I wish that there was a way to go through those and find optimal settings for different kinds of jobs. I remember Mike gave a talk a while ago on, I think it was Hub Zero, where he had looked at how students had gone through and altered their parameters to sort of find the optimal settings. And I wish there was a way to go through these. I mean, I have 300,000 jobs on our gateway. We could look at, if you're doing this kind of job, you want these settings because students constantly have errors that they run into. Whenever you're doing a job, it's important to have the correct settings to have it actually run properly. So that would be something in the path forward to some way to automatically look at past jobs and choose optimal settings. Because of the lack of resources for education for locally, it's important that Exceed keeps funding these gateway allocations for educational purposes. People are really focused on research and what kind of new research you're doing, but it's important to always understand that even if you're not doing cutting edge research, if you're doing some sort of educational work, that's extremely important because those students feed into future graduate students and postdoc who will be doing the research. And for education, especially, it's important to build a community because there are not a lot of faculty in each university who are well-versed in computations. And so bringing people together with workshops and meetings where they can meet other people and other faculty and learn how to do these computations, even through a gateway, I think is quite important.
Thank you very much. So I stop sharing now and try to come back on my screen. Good. So I've seen there are already questions. So thank you very much for the great introduction from all the 5 panelists. So the question from Rajesh, you want to ask yourself, Rajesh? You can unmute yourself.
Sure, yeah, thanks. I did want to add to my question as well, but I had a question for Kerk when he was talking about computational social science, because one issue we've seen is that some models need a lot of data, and usually the Twitter streaming, for example, if you're using Twitter, then the streaming endpoint may not really give you as much as you need, and you have to purchase the whole fire hose. So there's that access issue, that's one. And the other thing is social science and maybe even the health sciences, they need all these HIPAA controls and all these other controls as well, which may not be the case for other scientific domains. So there's this huge technology barrier. So I'm curious what our vision is for that going forward and how we can address some of these access and technology issues in these newer domains.
Thank you for the question. I was actually typing a response in chat, but I'm glad that we can actually talk about this conversationally as well. So first of all, I would first suggest that to perhaps over the next 10 years to envision the scope of computational science, social sciences to go beyond social media, even though social media is the most obvious one, to consider developing tools that may be able to import organizational data and community data with the consent of the organization and community, of course. So a lot of social scientists, social study organizations and groups that they partner with the gatekeeper to the organization, and with the consent form and with agreement, they can actually take data from the organization for analysis. So that if it is a partnership with an entity like an organization who owns the data, I think that may overcome the cost issue. That's one. Number two, I think that you were alluding to the privacy issue, and I think that by privacy issue in the health domain, and I think that certain organizations, if again, I'm kind of repeating the same argument here, is that if the researchers and research teams can work closely with the administrators of that data set and establish some confidentiality and anonymity agreement, that may be overcome. But I think that right now, because computational social sciences is such within gateways at such an early phase, we mostly think about social media data. But I think that if we expand our scope to include other types of data and then be able to establish confidentiality agreements, we may be able to overcome this limitation. And this is just my knee-jerk reaction. I welcome other thoughts as well from you and from others on the call. Thank you.
Yeah, thanks. I won't take too long. I just wanted to respond to that. But I do agree that it's good to have those at an institutional level. And I know John put in comments as well, saying this makes the case for a gateway. I did want to say that I haven't seen too many examples of gateways, or maybe there are a lot that work with data that needs these privacy controls. So maybe even we're looking at future technologies, that's something to consider as well, like having a common set of these technologies that we can leverage versus people having to figure these things out for themselves. Thanks.
Thank you. And Sean had also some ideas about it. He typed it in, yeah. So Sean, you would like to repeat your ideas?
Just for Rajesh. Yeah, we had a recent meeting with one of the SISE, the new director of SISE, and they were just talking about that they're recognizing that access to large data sets for supporting deep learning and AI and things like that is something that NSF is looking to support and recognizing as infrastructure. And so access to perhaps some of these social media data streams might be something also they would be investigating if we brought it up with them.
And we have directly also a question from Mike to you. So Mike, you want to say it?
Sure. Although I typed it so Sean could stare at it for a while because it's a little bit long. But a lot of times when we talk about interoperability, as gateway software people, we tend to think about, well, this software service needs to talk to that software service, needs to, talk to this one. And rarely do I see real solid examples of scientific tasks that need to be accomplished across multiple gateways connecting to different resources in different locations. A lot of times what I see is when people see that sort of opportunity for interoperability, they just grab the whatever code it is they would like to combine with their code and throw it onto the same gateway rather than undertake a big interoperability task. So how do we get to a point where we can define more of these things based on the science functionality and not based on our own sort of geeky computer science thoughts on how things should work?
I have a thought here. I just, one of the things I've been looking at is low code in environments. And I think that this is something that business has caught on to in a big way that academics, well, I won't say that it hasn't been done, but I think it hasn't quite caught on at the same level. I think what you're describing, right, is when you want to put things together, you wind up doing it yourself because we don't have all the plumbing in place to really just do things on the fly and connect them differently. But I think that's coming. I think that kind of thing has been built for business by many different companies, and I think it's just eventually we're going to have the tools in place for it.
So I have a comment also on that. So it looks like there is this concept called FAIR, findable and reproducible and interoperable and things like that. So for that, the resource or service need to be findable in a standard format. That means that if another gateway provides a particular service, it somehow needs to get published, and the other gateway or a service need to be able to discover it, and some standards need to be developed and adhere to for different gateways to be able to find if something can be sent and received and so on and so forth. Thanks.
Yes.
Okay, now to Sean. Try to answer the question.
I'll hop on. I'll extend some of those things. So yeah, just so, as I'm thinking about it, as he was talking about, yeah, the services, the gateways and the APIs and the things that sort of allow all these things to work need to advertise, yes, what they can do and their capabilities. And I did allude to what Maytal mentioned yesterday at the SGCI with the sort of computational resource and app resource things. I know there's efforts also for, because I'm on one of the working groups for looking at FAIR standards for gateways and virtual resource environments. So, what does that look like and how can those things be supported? So yes, definitely having those things be able to advertise themselves. And as sort of Steve was alluding to, the whole low code, no code, I think I agree that that stuff is coming. And I think that as we look at more projects that work with gateways and work with cyber infrastructure that integrates, artificial intelligence type things that can do recommendations and can, try and tie some of those things together. I think, yeah, researchers will start to be able to put those things together. But at the same time, the developers and the computer science folks who are doing the implementation, we have to take all those things into account and, be able to allow all these services to be able to advertise what they can do and then talk to one another at that level before I think it'll be the whole low code, no code thing can happen. So I think we need to work on that. And I think that we are in those stages of trying to implement those things together for better interoperability at the developer level so that, yeah, we can abstract one layer higher.
If I could make a clarification of my question, can I make a quick clarification of the question to follow right up on Sean? So when you say advertise what they can do, it's one thing to say, I've got a compute resource that has GPUs that look like this and advertise that. It's another thing to say, I can compute a Young's modulus based on this kind of input. At what level are we talking about advertising what we can do?
Well,
my answer that I had wanted to say, because I think the comment that if you build it and they know about it and they trust it, they will come. Because the question that Rajesh brought up about, taking material that is HIPAA protected and being able to anonymize and redact that to a point where people can work on it. The idea of having a bunch of different formats of data sets that all relate, but nobody can work with all of them at once because they have different layouts, different formats. I am lucky enough to work with a couple of gateways right now that actually offer those services, but nobody knows about them. And so if you have a better way of getting people to know that your gateway exists, then you're going to have more people coming to you with these questions and going, I can work with that. I know how to do that, and I can make that easier. Because once you set it up, this system that I work with called Clouder, you feed it a piece of data and it says, oh, okay, I've seen that before. I know that I need to put it into this common format so a bunch of other people can work with it. I need to anonymize it in this format so that this set of people can work with it. And for somebody else, I have a chain of things that I need to be able to run on it so they can do this. And the hard part that I see for science gateways over the course of the next 10 years is, in order to be able to meet these needs, people need to know about us.
So, and
Mark so just one more thing to address what Mike was asking about how do we know that this thing can run this particular or would address this particular problem. I think it's all about the sort of the resource description. The app descriptions need to be robust enough that they can be parsed out by whatever system like you want to do requests. There has to be some sort of either registry or some sort of federated network where those descriptions, I think, are shared within that whole ecosystem of things. And so I think the Gateways Community Institute is making progress towards that with the Gateways registry in those descriptions. And so I think within the next 10 years, I think there'll be something that will come out to enable what you're asking, Mike.
Hey, cool. Mark, your chance. This is a very energetic panel. I really like it.
Well, I was enjoying listening to the federated and interoperable, because that's important too. No, my only comment was when we talk about VR, because I mean, I'm older than 20, and I remember sitting in the SGI Silicon Graphics demo truck in 1998, and they were going to make VR a household name. So one of the things that I've noticed, one of my other hats, virtual production, if you just go to YouTube and look up how they made like The Mandalorian and things, this whole cave video side of it, where you're not necessarily wearing a VR helmet, which I think is the deal breaker in a lot of people. but you still create this immersive space, and you can still get up and go to the bathroom when you want to. But one of the things that's interesting is they're hitting massive amounts of compute problems as well, trying to make all this stuff work. So I think there's room there for some synergy. Hint, hint. That was it. And whether or not anyone's tried any.
Mark Perri?
Yeah, I just wanted to say, as far as interoperability, I know APIs are great, but
Mark Perri?
Yeah.
You have your hand up. You want to say something, or?
Can you hear me, Sandra?
I can hear you, Mark.
Okay, just, if there's a way I could mount a file system across these resources, I think that would be interoperability for me. Try to mount something from Expanse on Jetstream, for example. That would go a long way to helping. I know there's Globus to transfer data, there's SSHFS, but that doesn't work very well. So I think a base level interoperability would be nice in the next 10 years.
So I just had a comment on Mark's VR statements. I think one of the things, they were going to make VR a household word decades ago, and it didn't happen. I think sometimes technology promise materializes before the technology. And I think VR is an example of that. But I think that the recent headsets, which are only $300 and are completely wireless, yes, you have to strap on, a thing on your head. But those two barriers, cost and the need to set up, are big hurdles that have been removed. And I think the next generation is going to be AR, augmented reality, where you have lightweight glasses which you can wear, and you can still see the real world with your images overlaid, and so you'll be able to go to the bathroom and and other such things. I think it's close.
So, Mark, I just would like to make a comment about interoperability. I think that's critical, but there is a good citizen version of interoperability, and there's a rapacious version, and I see them both happen. The bad one is where people say, "I'm interoperable. I will be able to launch your instance from within my environment." That is, I eat you. And the good citizen one is say, I want to figure out a way that I can launch my environment within your environment. And if you can do the same, then that's kind of a true collegiality. And those are very different modes of interaction. One's very aggressive and one's very cooperative.
So thank you very much, everyone. I got kicked out in between, kind of, so I lost the connection to the discussion. So we are at top of the hour. I hope, Mark Perri, you could say what you wanted to say, because I've seen your hand up.
I got it. Yeah, thank you.
Great. And I would like to thank the panelists again and for lively discussions. And so we are going now into the working sessions, so that we are all going out of this room, and the next program topic, the working session. Thank you.